Okay, so graphing inequalities. So we have a graph here, and the question says shade the area where x is greater than 2 and where y is greater than or equal to 3. Okay, now what we need to do is to differentiate between greater than and equal to. And this also applies for less than and equals to. If anything is and equals to, then the line that we draw will be a solid line. If it's greater than or less than but not equal to, then we draw a dotted line. Okay, now the reason we do that is if we're just given the graph and we have a line here where x is 2, if we put in everything as solid lines, we don't know whether x is greater than 2 or greater than or equal to 2. Okay, as we did with the number lines, we have empty circles for less than and greater than, and we have full circles for less than and equal to and greater than and equal to. Okay, so now drawing the lines is very simple. So where x is greater than 2, so we go to where x is 2. So if I do this in a different colour, let's do it in green. So if x is here at 2, okay, x here is 2, x here is 2, and here, and here, and here. Okay, so anywhere on this line x is 2. Okay, it might seem a bit counterintuitive because everybody wants to make x equals 2 along this line, but that's not true because y is 2 anywhere on this line. So here x is 2 anywhere on this line, but the y values are rising and falling. Okay, so that's something that you just need to get used to. So if x is greater than 2, okay, so I've put in my dotted line to show that it's greater than, and then what I do is I just flick a few lines on the side that I'm interested in. Okay, because if x is greater than 2, then x is 3, 4, 5. We're only interested in this side of that line. So I just flick a few faint lines here to show me that I've no more interest in this part of the graph. Okay. Now, if y is greater than or equal to 3, so this is a solid line. So if I go to where y is 3, so anywhere on this line y is 3. Okay, so y is 3 here, y is 3 here, y is 3 here. But I'm only interested where y is greater than 3. So I'm only interested in this bit. So I'm only interested in the bit to the right of the x-axis, or the right of the x-line, and above the y-line. So now I can just shade that in. You can cross-hatch it, you can colour it in, whatever works for you, as long as it's apparent to the examiner that this is the area that you're concerned with. Okay, so if it's less than or greater than, it's a dotted line. This is important. If it's greater than or equal to, or less than or equal to, then it's a solid line. Okay, and then you just draw the lines and then shade the area accordingly. Okay, so what I'm going to do now is pause the video. I'm going to put up a fresh graph and we'll do another one. Okay, so I have a fresh graph, and again shade the area where x is less than or equal to 4, where y is greater than or equal to 1, and then where y is less than or equal to x. Okay, now the first thing I do is I decide whether they're straight or dotted lines. So this is and equals to, so this is going to be a straight line. Where y is greater than or equal to, so I can see again this is going to be a straight line. And where y is less than or equal to x, so I can see that this also is going to be a straight line. The reason I do this is because once I've done this, I just look at the lines and then know that I've got to put in straight or dotted lines. It just helps me. Okay, so now I can put these lines in. So where x is less than or equal to 4, so I go to where x is 4, so anywhere on this line, and I know that I'm only interested where x is less than 4, so I'm only interested in anything this side of the line. Okay, so now I put in the next line. So the next line is where y is greater or equal to 1. So I go to where y is 1 and I put this line in, and I'm now only interested where y is greater than 1. Okay, so I'm only interested where y is greater than 1. So I'm only interested in the left, to the left of this line and above this line. So I have no interest in any of this in the graph. Okay, now where y is less than or equal to x. Now this is the bit that most people find a problem. If I was to draw the graph y equals x, I would then work out the values, because I know that this on a graph, okay, is going to give me a straight line. I know that's not a straight line, but I'm old and my eyes are going. So I know that this y equals x is going to give me a straight line at an angle. Now one of the things that you need to know, okay, is that when you draw this line, the y equals x, then it will go at 45 degrees, okay? It will go diagonally through all the squares, okay? So let's take it, say, from there it's going to go through there. So let's just link it up. That's going to go through there, through there, through there. Okay, so just make sure that I've got it right. Okay. So this line, excuse me, is going to go at 45 degrees. Okay, so it's going to go diagonally across all the squares. Okay. And this line you must be able to drop in at a moment's notice. So if you know that it's 45 degrees, it will always pass through the point of origin, and you know it's going to hit all the corners of the squares. So where y is less than or equal to x, so if it's y is less than, it's going to be underneath the line. If it was y is greater than x, it will be above. But here y is less than x. So now we can see that we're only interested in to the left of the x-axis, or the x line, above the y line, and beneath this y equals x line. So we are only interested in this triangle. Okay, now just as a tip, at GCSE level it will always be the area that's trapped. Okay, maybe I shouldn't tell you this, but I will tell you. At this level you are only interested in the area that's trapped in between the lines, okay? Because the only other solution will be everything outside of that and not this, and that's very unlikely to happen. So it's always the area that's trapped here. Okay, so I'm going to do just one more, just to make sure that you've got this. Okay, so I'll clear this graph and we'll put on another one. Okay, so here we have a similar question. Shade the area where x is less than 5, where y is greater than 2, and again where y is less than or equal to x. So first off, I look at the signs. Now this is less than, so this is going to be a dotted line. This is greater than, so again a dotted line. Now this is less than or equal to, so I know that this is going to be a solid line. Okay, so where x is less than 5, okay, so where x is less than 5, so x is 5 right on the edge of this graph here. So dotted line down here. Okay, so obviously I'm only interested in the left of that line because we're right on the edge of the graph here. So we're interested in what's to the left of that line. Now y is greater than 2, so I go to where y is 2 and I put in my dotted lines. Yours will be a lot straighter than this, I'm sure. Should use a ruler. Now where y is greater than 2, so I'm only interested really in anything that's above this line. So I'm interested in what's to the left of this line and what's above this line, because y is greater than 2. Now y is less than or equal to x, so we draw the line y is equal to x, Okay, so it's going to cut through all these lines, all these corners, okay, and it's going to go through the point of origin. Okay, so I can take it to there. So you can see it's cut at 45 degrees through all these squares. So you don't have to work out a little box x equals 1, 2, 3, because you should know this. Now we have y is less than x, so we're only interested in what's beneath this line. And as I said to you before, we're only interested in anything. Sorry about that, that's my phone. We're only interested in anything that's trapped in this shape. Okay? So this is how we graph inequalities. It's nice and simple. So just practice and you'll be fine.